This is another geometry lesson. It is about intersecting lines and vertically opposite angles. We start with these two straight lines. Intersection simply means meeting. So when we talk about intersecting lines, we simply mean lines that meet. Two lines can only intersect at one point. We shall demonstrate the relationship between the angles at the point of intersection or the point of meeting. This is an angle of 58 degrees. You should be able to work out the measure of this angle here, because we know angles on one side of a straight line add up to 180 degrees. So it may not surprise anyone at this point when we measure this angle and find that it is equal to 122 degrees. Now this relationship is true for all values of angles. So whatever the values of these two angles, they should always add up to 180 degrees. Can you try to figure out what measure of this angle would be? This one here. Pay attention to this straight line, and you will be able to see without difficulty that this angle here is equal to 56 degrees, because the sum of these two again has to be equal to 180 degrees. And so on. The final one should be easy to guess. Again, it is by considering either this straight line and the sum of the angles on this side of it, or you could focus on this straight line and then see the sum of these two angles is 180 degrees. In that very simple exercise, we have demonstrated that opposite angles across the point of intersection of two lines are always equal in measure. This relationship is known as vertically opposite angles. The red angles are vertically opposite. The other angles are also vertically opposite. We summarize this by saying that opposite angles formed by a pair of intersecting lines are always equal. Let us mention the special case of intersecting lines, the case of perpendicular lines. A pair of lines is said to be perpendicular when they meet each other at 90 degrees or at right angles. So if one of the angles is 90 degrees, we say the lines meet perpendicularly or the lines are perpendicular. Obviously, following the logic we've just observed, if one of the angles is 90 degrees, the other one opposite it should also be 90 degrees, and it follows naturally or logically that the other two are also 90 degrees. So this is a special case of intersecting lines. We say that perpendicular lines intersect or meet each other at right angles. One last note before we leave the intersecting lines. When the lines are not perpendicular, which is a general case, we say they are oblique to each other. The word oblique means that the lines meet at a slant. They are neither perpendicular nor parallel to each other. This question requires you to find the value of x and explain your working. X is this angle here. In this particular case, we have not a pair, but three lines intersecting at this point here. This should not be a source of confusion, because to apply the principle just learned, we just need to focus at two lines at a time, and that will reduce the confusion. So let's have a look at this line to start with. And before we even answer the question, let us look at the angles on one side of this line. From an earlier lesson, we already know that these three angles have to add up to 180 degrees meaning that this missing angle here must be equal to 19 degrees. You do your addition and you will confirm that this angle must be 19 for this to add up to 180 degrees. So as soon as we work that angle, then focus on these two lines and it is immediately clear that 19 degrees is the vertically opposite angle to x. So x must be 19 degrees. Our reason is vertically opposite angles are always equal. That's an easy question worth 2 marks. Example 2. Find the values of y and z. Explain your working. We will start by finding the value of y. Do not be tempted to apply the vertical angles theorem blindly here, because there is a little trick. If we highlight this line, we can tell it is not straight. If we were to do this on a piece of paper, we would use a ruler to be sure that this is not a continuous straight line. So we cannot apply the vertical angles at that point. But there is a way out. Let's focus on this line, and we can tell that all these angles are on one side of this straight line, meaning that we can add them all up to get 180 degrees, which means by subtracting 55 and 29 from 180 degrees, we find that y is equal to 96 degrees. The reason is simple. Angles on a straight line add up to 180 degrees. Continuing now to find z, we need now pay attention to this straight line. And again, we add these two angles up. It should be 143, their sum. And when we subtract that from 180 degrees, we find that z is 37 degrees. The reason we need to give is just the same, that angles on a straight line add up to 180 degrees. So in a way, this question is not exactly about vertical angles, but it is a setup to tempt a lazy mind to assume that all the angles are vertically opposite. But actually, the real reason we need for solving this question is angles on a straight line, which we have learned before. We shall look at one more example. JAL and KAM are intersecting straight lines. Find the value of angle LAM and explain your working. So here is angle LAM. It is given to be equal to 11x minus 3 degrees. We note that these two angles are vertically opposite. Therefore, we are justified to equate them. 11x minus 3 is equal to 9x plus 7. We need to simplify the equation so that x's remain on one side of the equation, and this is the result. The 9x on the right side cancels out, and the new equation is 11 minus 9, which gives us 2x minus 3 is equal to 7. The numbers have remained unchanged. Next, we need to move negative 3 to the right side so that we can isolate the term containing x. This requires addition of 3 to both the left side and the right side. 2x is equal to 10. Note the negative 3 and positive 3 cancel out. Dividing both sides by 2 gives us x is equal to 5. Finding x was not our final goal. The question requires us to find the measure of the angle LAM. To do this, we shall replace the x in this equation to find that angle LAM is equal to 11 times 5 minus 3, which is equal to 55 minus 3, which gives 52 degrees, as the final answer, and that is the value of the angle LAM.
Watch the next video. Share with a friend. Subscribe and hit the notification bell icon. Thank you for watching.